Lesson 38, Area of Triangles. This is a 3-page lesson. Let's take a look at part 1. Find the base and height of each triangle. Use a solid line for the base and a dotted line for the height, and be sure to corner the right angle. The lengths or approximate lengths of some of the sides are provided as reference. Let's start with the two right triangles. Here we have a dark gray right triangle and a light gray right triangle, and notice that they're the exact same size and same shape. So we'll use a solid line for the base, and we'll use a dotted line for the height. This is what students' work should look like. Notice that we used a solid line for the base, which measured 1, 2, 3 inches, and we used a dotted line for the height, which measured 1, 2, 3, 4 inches. Also, notice that the height and the base met at a right angle. Here, we label the light gray right triangle the same way. Now let's take a look at the two acute triangles. We used a solid line for the base, which measured 1, 2, 3 inches, and we used a dotted line for the height, which measured 1, 2, 3, 4 inches. To find the height of this triangle, we started at this vertex, then we dropped straight down until we reach the base. And notice that the height and the base meet at a right angle. Now let's take a look at the two obtuse triangles. In the dark gray obtuse triangle, we used a solid line for the base, which measured 1, 2, 3 inches, and we used a dotted line for the height, which measured 1, 2, 3, 4 inches. To find the height of this triangle, notice how we had to extend the base by drawing a dotted line. Then, we went to this vertex and dropped straight down until it formed a right angle with the base. This is what it looks like when both obtuse triangles have been labeled. The light gray obtuse triangle also has a base of 3 inches and a height of 4 inches. Let's move on to part 2. Use the grids below to find the area of each triangle on the previous pages indicated below. So we'll place our two right triangles into this grid here. We'll place our two acute triangles into this grid here. And we'll place our two obtuse triangles into this grid here. And notice that each grid measures 3 inches wide and 4 inches tall. And the area of this grid is 12 square inches. Let's start with our two right triangles. Let's place the dark gray right triangle into the grid first. And now here's the light gray right triangle. And to make it fit into the grid, we're going to rotate it. And now, notice how they both fit perfectly into the grid. Now let's find the area of the dark gray right triangle. Notice that the dark gray right triangle takes up 1/2 of this rectangular grid. So to find the area of the dark gray right triangle, don't use the base times the height. Use 1/2 the base times the height. Let's write that down here in the workspace. Area equals 1/2 base times height. Let's go to the next line. Write down 1/2. The base is 3 inches. The height is 4 inches. Let's simplify. We can divide by 2 and divide by 2. 1 times 3 times 2 equals 6. Inches times inches equals inches squared. So the area of the dark gray right triangle is 6 inches squared, or 6 square inches. Let's take a closer look to make those 6 square inches more obvious. Here we have only the dark gray right triangle. And once again, we said that the area was 6 square inches. However, it's not obvious where those 6 square inches are located. Only 3 of them are clear. Here we have 1 complete square inch. Here we have 2 complete square inches. And here we have 3 complete square inches. However, this part here is not a complete square. This part here is not a complete square, and so on. So let's do a little cutting. We'll combine shapes, and the square inches will become more obvious. We're going to make a cut right here along this line, and we'll make a cut right here as well. Then we'll do some rearranging. This is what it looks like after we've made the cuts. Notice how we've made a cut right here, and notice how we've made a cut right here as well. And now we can do some rearranging. So let's take this piece, rotate it, and move it up here. And let's take this piece, rotate it, and move it down here. And now it's much easier to see 6 square inches. Here we have 1 square inch. Here's 2 square inches. Here we have 3 square inches. 4 square inches. 5 square inches. And 6 square inches, just like it says here. Now let's work on our 2 acute triangles. Let's place the dark gray acute triangle onto the grid first. And now let's place the light gray acute triangle onto the grid. And if we rotate it this way, notice that we have an extra piece here on the right, and we're missing a piece here on the left. So let's make a single cut and do some rearranging. We're going to make a single cut along this line, which is the height of the light gray acute triangle. This is what it looks like. We've made a single cut along the light gray triangle. And now we can move this extra piece to the other side. And now both the dark gray and the light gray acute triangles fit inside the rectangular grid. Now let's find the area of the dark gray acute triangle. Notice that the dark gray acute triangle took up 1/2 of the rectangular grid. So to find the area of the dark gray acute triangle, don't use base times height, use 1/2 base times height. Let's write that down in the workspace. Area equals 1/2 base times height. On the next line, here's 1/2. The base is 3 inches. And the height is 4 inches. Let's simplify. We can divide by 2 and divide by 2. 1 times 3 times 2 equals 6. Inches times inches equals inches squared. So our final answer is an area of 6 inches squared, or 6 square inches. Now let's work on the 2 obtuse triangles. Let's place the dark gray obtuse triangle onto the grid first. And you'll notice that right away, it doesn't fit. This section of the dark gray obtuse triangle sticks out. Now let's place the light gray obtuse triangle onto the grid. We'll rotate it, place it onto the grid, and you'll notice that the light gray obtuse triangle doesn't fit either. Part of the light gray triangle sticks out, and also notice that on this side of the grid, we have all these empty spaces. Before we do any cutting, let's tape the pieces together first. Notice that I've taped the dark gray and the light gray obtuse triangles together along the longest edge. And be sure to tape along the entire edge. Now let's make a single cut. We're going to make a single cut right along this line, and notice that the cut will go through both the light gray and the dark gray obtuse triangles. Here's what it looks like after the cut is made. Notice how we made a single cut right along this line, and now we can do some rearranging. Let's take this piece that sticks out and we'll move it over to the other side. And notice how it fits perfectly within the grid. Now let's find the area of the dark gray obtuse triangle. The dark gray obtuse triangle took up 1/2 of this rectangular grid. So the area is equal to 1/2 base times height. Let's go to the next line. Here's 1/2. The base was 3 inches, just like you see here. So write down 3 inches. The height was 4 inches, just like you see here. So write down 4 inches. Let's simplify. We can divide by 2 and divide by 2. 1 times 3 times 2 equals 6. Inches times inches equals inches squared. So the area of the dark gray obtuse triangle is 6 inches squared, or 6 square inches. Here's an important observation about the lesson. The dark gray right triangle, the dark gray acute triangle, and the dark gray obtuse triangle all had the same area of 6 square inches. And this happened because they all had the same base of 3 inches and the same height of 4 inches. Here is a right triangle with a base of 3 inches and a height of 4 inches. Here is the acute triangle with a base of 3 inches and a height of 4 inches. And here is the obtuse triangle with a base of 3 inches and a height of 4 inches. So remember, the area of a triangle is always 1/2 the base times the height, no matter what type of triangle it is.